Hello everyone, myself Rashmitha, faculty of BCA department. So today I will be doing the concept of graphs. Now in the graph we will be dealing with the introduction, definitions, types of graphs, degree and a neighborhood of a node and the conclusion. So first we will see what is graph. Graph is a mathematical structure which is used to particular functions with the help of connecting a set of points. So a graph is mainly used in the field of linear graphics, or else even it is used in other applications like chemistry, physics and computer science field also. And the graph is mainly created by using the vertices and edges, where the vertex and the edges, where the edges are used to connect the vertex. So the definition of graph: a graph G of V comma E consists of V, a non-empty set of vertices, and E is a set of edges that are used to connect these vertices. Now you can observe here it is a graph where A, B, C are vertices and AC, BC and AB are the edges. So types of graphs. So we will see the next which are the types are there under a graphs. So simple graph, multi-graph, pseudo-graph, simple directed graph, mixed graph and a complete graph. So first we will see what is simple graph. A graph with no loops and no parallel edges are known as a simple graph. So the graph is here, you can observe, where there are 4 vertices are there and total 6 edges are there. In this you can observe there is no loops as well as no parallel edges. Such kinds of graph is known as a simple graph. Next is a multiple graph or a multi-graph we will say. Now multi-graph is nothing but a graph that have a multiple edges connecting to the vertices. You can observe here the graph. Here there are total 4 vertices, 1, 2, 3, 4, where the edges want to have a 3 edges, that is 3 edges are there. That means for the same vertices there are 3 edges, that means it is a multiple edges are present for this. That's why it is known as a multi-graph. The next is a pseudograph. A pseudograph that contains loops as well as multiple edges connecting the same pair of vertices. So in this graph you can observe there are 3 vertices, and under 3 vertices, for each vertex you can observe here there are 3 loops, and whereas here 1 loop, and the multiple edges were connected. That's why it is known as a pseudograph. Next we will see a simple directed graph. Now simple directed graph is nothing but it is a directed graph where every edges were directed. So in the example you can see where the every edges were directed. If the direction is there, then that such kind of graph is known as a simple directed graph. The next one is a mixed graph. Now mixed graph is nothing but a graph with which have a some edges are directed and some edges were not directed or undirected. Such kinds of graph is known as a mixed graph. Mixed graph. Now mixed graph is nothing but a graph which has some edges were directed and some edges were undirected. Such kind of graph is known as a mixed graph. So in the figure you can observe there are total 5 vertices. In that the edge 1, 3 has a directed edges, whereas 3, 4 and 5 has a directed edges and 4 has a directed edges. Such kinds of graphs are known as a mixed graph. You can observe here there are some directed edges and there are some undirected edges are also present here. The next one is a complete graph. A graph in which exactly one edge is present between every pair of vertices. Such kind of graph is known as a complete graph. So here you can observe there have taken 3 types of graph, where complete graph with n vertices which is denoted by kn, where n equal to 1, 2, 3 so on. That means here you can observe the first figure, that is there are two vertices, that means n equal to 2. That is a K2 graph where between two vertices there only one edge is present. That is a complete graph. That is K2 complete graph. The next one is a K3 complete graph, in the sense 3 in the sense n equal to 3, where three vertices are present, where between each vertices there is only one edge is present. Even in the last graph you can observe it is a K4 graph since four vertices were present. So far we have seen the types of graphs. Now we will move on to the degree of a graph and a neighborhood of a graph. Now degree of a graph or a degree of a vertex, it is nothing but the number of edges connected to the vertices. Degree of a vertex is nothing but the number of edges connecting to the vertices. Now here you can observe it's a graph where there are total 5 vertex are there, or a vertices is present. In that, now we will see the first one. The first point we will name it as A, and the second point is B, and the third point is C, and the fourth point is D, and the fifth point we will name it as a E. Now you can observe in the first point we name it as a A. Now we have to see for the first point how many edges were connected to that vertex. Now here you can observe there are only 2 edges were connected to that point. That means the degree of A is 2. Whereas in B you can observe there are 2 edges were connected to the point B. That means the degree of B is 2. It goes on similarly. Now when it comes to the degree of E, that is E point, you can observe there is no edges were connected to the point E. So degree of E is equal to 0. So when in the vertex their degree is 0, means it is a isolated point or a isolated node, we will say. This is regarding the degree of a vertex. Next we will see a neighborhood of a node or a neighbors of a node. Now neighbors of a vertex B in a undirected graph is the set of all vertices adjacent to V, and it is denoted by n of V. We have to see which are the vertices were adjacent to the vertex V. Now in this graph you can observe there are total 4 points, that is 1, 2, 3, 4, that is the 4 vertices. Now if I consider the first vertices 1, you have to see for this which is the adjacent vertices. You can observe here for the 1 the adjacent vertices is 2 and 4. So n of 1 is equal to the adjacent vertices are 2 and 4. Now in the case of 2, if I see the vertex for the 2, the adjacent vertices are 1 and 3. So the n of 2 is equal to 1, 3. This is regarding the neighborhood of a vertex or a neighbors of a node. Now next we will see, we have studied a degree of a vertex and a neighborhood of a node. We will solve based on that some sums. So what are the degrees and neighborhood of a vertices in the graph displayed? So the first graph, if I take here the first graph, you can observe there are total 4 vertices are there, that is A, B, C and D. You can observe in A there is a one loop. Now loop is nothing but where the edges are connected to the vertices, that edges will start from the same vertex and end at the same vertex. That such kind of edge is known as a loop. Now we will see regarding the degrees, how we can find the degrees for that graph. I'll draw it on the board. We will see that. Now the first point is degree of A. Now for the vertex A, we have to see how many edges were connected. You can see here the edges AD, edges AB and the loop itself. That means there are total 3 edges were connected to the vertex A. That means the degree of A is equal to 3. Similarly, we will go for a degree of B. Now degree of B, we have to see how many edges were connected to the vertex degree of B. There are 3 edges were connected to the B. That means the degree of B is 3. Next we will see degree of C. Now for the degree of C, you can observe there are total 3 edges were connected. That means the degree of C is 3. And even in the degree D, we have to see how many edges were connected to the point D. You can observe 1, 2, 3, 4. Total 4 edges were connected. That means degree of D is equal to 4. This is the regarding degree, how to find the degree of the vertex. Next we will see neighborhood of a vertices. How we can find the neighborhood of a vertices. Now neighborhood of a vertices is nothing but it is a vertices which are adjacent to the vertex. Now we will see how we can find that. Now neighborhood of a node is denoted by n of v. So we will take it here. First one, n of a. So n of a. So n of a, how many adjacent vertices are there? For that n of a we have to check. Now here it is a D and B, and when the loop is there we have to consider that loop also. So the neighborhood of a is a comma B comma and D. These are the neighborhood of a node of A. Next we will go for a B. Now so n of B is which are the adjacent vertices. There we have to see. Here the adjacent vertices are A and C. To see A and C, that we have to write. Next n of C. Now for the vertex C we have to see which are the adjacent vertices, that is B and D. B and D. Next we have to see which are the adjacent vertices for the D, that is A and C. So n of D is equal to A and C. This is regarding degree of a vertex and a neighborhood of a vertices. Next, so in today's session we have seen about the graph, what are the different types of graphs, and the degree of a vertex and a neighborhood of a node. So all these whatever we have studied, these are all regarding to the graphs which will helps in the futures as well as in other application also it is used, especially in GPS. Now the application of graph, when I come to say, the GPS which we use it in our daily life in the mobiles to navigate the destination or to see the direction. So that GPS is helpful in the graph structure to track the path or to get the direction of the route. This is mainly useful. So graph is very useful in our daily life situations. Thank you.